Hello to everyone. Now I am going to present under the topic of two-port network. So generally you should know the concept of two-port network. So what is the two-port network? First of all, before going to a two-port network, we must know what is a network. A network may be used for presenting or representing either a source or a load. So why we are presenting here, the source or load will be presented for the variety of purposes. So that is the network. So here my pair of terminals, I am using a pair means we are using two type of terminal. So the pair of terminal at which a signal may enter or signal may leave, that is called a port. What is a port? A port is nothing but a terminal. It consists of a sub-pair. A pair at which a signal it may be enter or it may be leave. That is known as a port. So how it a two-port network? A two-port network is a device in which signal may enter or leave. So this is the concept behind the two-port network. So you have the two port at port number 1 and port number 2. So it have a constant voltages and current. So these two will be taken place, and these two the signal may apply or signal may leave. So this is the concept of a two-port network. Okay. Now let us take one example here. See, you are taking a 4.1 diagram. It shows a two-port network. Here the four terminals have been ported. At port, it may be paired in the left side and right side. At 1, 1 dash and 2, 2 dash. So the terminal 1, 1 dash together constitute a one port. On the right hand side, we have a 2, 2 dash. It constitutes the other port. So the two ports, which these two forms a two-port network. So this is the example of two-port. We are having the either pair of terminals at both ends. The signal may enter at one end and signal may leave at the other end. So this is a two-port network. So here the port which has a no source, that the branches. If the branches that has a no sources means it is a passive port. If it has some sources in it, it is known as active port. So you should know that differentiate, how to differentiate this one. So active port is nothing but the port which have a source. The passive port is nothing but it does not contain any source. So it consists of a active and passive ports. Based, and also they have a transmission lines. The transmission lines is also presented in this circuit. Let us see. Here in this diagram we have the voltage and current assigned to each port. Voltage and current assigned to each port. At input port we have the current V1 and I1. At output port we have the V2 and I2. So it is assumed that I1 and I2 entering the network. So the signal is entering here at the upper terminal 1 and 2. So another one, in this time the voltages are dependent and independent variable. So the two types of variables are present. First one is independent and another one is a dependent variable. So these two combined form a two-port network. Okay, let us see the types of the two-port network. First we have to see the Z parameter. So Z defines the impedance of the network. We must know what is impedance. The symbol is Z. So first one is a open circuit impedance. We have two types of impedance here. First one is an open circuit and second one is a short circuit. Let us discuss about the open circuit Z parameter. Okay, so this is a basic block diagram. So simply we have the two port. It is a two port network terminated at 1, 1 dash and 2, 2 dash. The current entering which shows the I1 and the current is leaving shows the I2. That is a two port terminal. So the Z parameters consist of both ports. Here V1 and V2 considering a dependent variable and I1 and I2 are the independent variable. Here the current acting as an independent source and voltage acting as a dependent source. So let us form the equation at port 1, 1 dash. Let us take V1. I am considering my left hand side circuit, that is V1 voltage. When you apply the V1 voltage, how the equation will form? Z11 into I1 plus Z12 into I2. So these are the consideration when my signal enter into the network. And again in case of right hand side we are considering V2. So what is V2? Z21 into I1 plus Z22 into I2. So these Z11 and Z22, these are the network function. How the network is going to function in your two-port network. That is a impedance. That is known as the impedance. Yes, these two form the matrix equation. We all know what is matrix. V equal to Z into I. So Z represent the impedance and I represent the current enter or leaving the network. So now we are going to form a column matrix. that is here we are considering V1 and V2, and Z here we are representing a square matrix, that is Z11, Z12, Z21, Z22. So these are the variables we have to taken into this account. And finally we are writing the open circuit impedance as V1, V2, that is V is equal to Z into I. So we have to take it in that format. So V1, V2 in one column matrix, and Z parameters are comes under the square matrix, into the current will be multiplied. Okay, now this is the circuit. So let us consider, suppose if port 2 dash is left open circuited, that time if any open circuited condition takes place, here there is no current will enter the circuit. So I2 equal to 0. So you can consider port 2 dash, that is left open circuited, which means there is no current flows in the port. So that time I2 equal to 0. So what is your Z11? That is V by I, V1 divided by I1. So here I2 equal to 0. Similarly, for other condition, port 11 that is left open, that time what will consider I1 equal to 0. So that only the equation they are formed. From that they are going to consider the Z parameter, that is a open circuit impedance. Okay, this is the derivation of the Z parameter. Thank you.